So in this case, we are going to consider our typical exam question, which is for our preparations as we are preparing for our exams, which are ahead of time. So given this question paper, we are going to consider our questions quickly as we know that now it's our time for revisions as we are preparing. All you need is to understand the basics. So make sure that you go through your instructions, the information that you're given. Mostly, make sure that all the calculations are clearly shown. Clearly show all the calculations, the diagrams, the graphs, whatever that you're given there. Make sure that you present properly. And also, in terms of your presentation of your work, make sure that you properly present your work in your writing and also your answers to two decimal places unless stated otherwise. So that is the major part. Like I said, we are not gonna waste our time. Let us quickly rush through our questions. We are given the first part of our question, which was to solve for x. So it's unfortunate that the question paper that we are having is not that much clear, but we're just going to write down these questions so that we can properly see that it was to solve for x on question number 1. That's the first part that we're given there. All right, let me do it like this. So we are given solve for x. 1.11, we are given 2x squared. All right, so let me just have my question. I can even just write it this side. All right, so we're given, that is our first question. This was 2x squared plus 5x. So this is equal to 0. That is what you're given. So if we're to consider, we can see that this is a quadratic equation. The highest exponent, the highest power that you're given is 2. The highest power is 2. So you're supposed to actually use the quadratic formula. You can use your completing of the square method. You can use your factorization method. So of all these methods, which is the basic? So you can see that, guys, this factorization is the basic one. Check the issue of the marks that you're given. 3 marks, which is fine. But if we are given a question like just solve for x, we're not given correct to 2 decimal places or to 1 decimal place. That one, it is best for you to just use your factorization. So factoring out x, which is common in both terms that we are given, that was going to give us 2x. Remember, when you factor out this x, you must divide 2x squared divided to this x. So this was going to be this was going to give us 2x. So that was going to be 2x. You do the same thing on this plus 5x. So if you divide by x, as you can see, guys, x and x was going to cancel and you remain with a 5. So this is what you're having. From the zero concept, we do understand that the product of these two terms, for it to be equal to 0, one of these terms must be equal to 0. So meaning to say, it is either this x, it is supposed to be equal to 0, or we are having this bracket, which is given as 2x plus 5, which is also supposed to be equal to 0. So from the first one, already we have the solution there. We are already having the x value. X is equal to 0. What about the second one? We have to solve for x. So solving for x, we can take out the positive 5 to the other side. That was going to give us a negative. Remember, this is a positive. So the moment jumps the equal sign, it changes. Then divide by 2 to obtain the value of x. Our x was going to be minus 5 over 2. So this is what we're having. 2 possible values, x, which is equal to 0, and the x, which is equal to the minus 5 over 2. So like I said, questions can be like that. You have to consider the method. Even if we're to use the quadratic formula, we are going to still have that same values of x. You are not given the method that you use. So you can use any. All right. Considering 1.12, we are given again to solve for x. This is minus 4x squared plus 3x plus 6 is equal to 0. Answer correct to 2 decimal places. In that case, never try to use your factorization. Once you're given instruction to 1 decimal place to 2 decimal place, they actually know that the answers that you're going to have there are not exact answers, meaning to say we do not have the factors that we can use for our factorization. So in this case, we are supposed to use our quadratic formula for 3 marks. We can use our quadratic formula. We can also use the completing of the square method, where the quadratic formula is used. Completing of the square method is used. All right, so let's consider our equation. This was minus 4x squared plus 3x plus 6 is equal to 0. So using or starting with the quadratic formula, if we are to use our quadratic formula, remember it states that x is equal to minus b. This is plus or minus the square root of b squared minus 4ac everything over 2a. So we have our quadratic formula. Substituting the values that we have already, our equation is in the format that we actually expect our quadratic equation to be. Remember your format, ax squared plus bx plus c is equal to 0. So you can see that our a is minus 4, our b is a positive 3, and our c is a positive 6. So that is how we're going to take our values. So let us substitute. X is equal to minus, remember b, the coefficient of x, which is a 3. So that's minus 3 plus or minus the square root of b squared, the same b, meaning to say the 3 that we had, minus 4 times a, which is a minus 4, our c, that's a positive 6. All right, you could have some, they want to avoid working with a negative. You could have avoided that one. All right, let me just finish up this one. 2 times a, our a is minus 4. So we're just taking the coefficients, like I was saying that we are supposed to have these. This is our a, this is the part of our b, this is our c. And also saying you could have actually changed this equation to the manner that you understand. You are given this equation as minus 4x squared plus 3x plus 6 is equal to 0. So you can say, okay, I want to avoid working with a negative value here on a. So some of you want to avoid that. But using the quadratic formula, there's no need. Yes, you can do that. Divide by a negative each and every term. So meaning to say that was going to be positive 4x squared, positive, negative, that was going to be negative, positive, negative, that's a negative, which is equal to 0. So meaning to say the equation that you're now solving is this one. And when you are using this equation, it means your A was going to be a positive 4, your B was going to be a minus 3. That is what you're going to have. And your C was going to be a negative 6 if you're using it this way. And you can use your quadratic formula. So changing that does not affect our solution at all. We are going to have same answers. So you can actually work it from that way. All right. So working out with this, like I always say, guys, try by all means to simplify what is inside of the square root. So that was going to give us minus 3. Simplify these numbers properly, you're going to obtain 105, everything over 2 times negative 4, which is minus 8. So we are going to obtain two solutions. One from a plus, remember, another one from a minus. So by inserting our values on our calculator, the first value was going to be negative, remember, or another x was going to 2 decimal places as we are given our instruction. All right, so this is what we have. Let me just have our calculator here. That's a minus 0, comma. All right, sorry, we need this one. Minus 3. Okay, can I have plus the square root of 105? So that's the square root of 105, everything over a minus 8 like this. So you're going to have your answer negative 0, 9058. Then you can even round off. Remember, this they say to 2 decimal places. So go to the shift, to the setup. Then you can fix this on number 6. Fix to 2 decimal places. You're going to press a 2 here. So your answer will be to 2 decimal places. Then let's change this to a minus. Remember that just remove this plus and put a minus. So we're going to have 1,66. So this is how you could have obtained your solutions from this one. All right. So you just have to work out, guys, as many questions as you can. So this was from the quadratic formula. But remember, I have expressed these methods, quadratic formula, the completing of the square method. So we need also to understand for those who are into the completing of the square method, because in this case, you're not like forced to say use this method. No, they just say solve for x. You are the one who is supposed to choose, and completing of the square method is part of our syllabus. So for those who are using completing of the square method, remember that the coefficient of x squared must be a 1. There we are having a minus 4. We are supposed to have a 1, not a minus 1, not a positive 2, but 1, like we are supposed to have it as x squared, having a 1, direct 1. So what can we do to obtain a 1? We are supposed to divide by the coefficient that is given of x squared so that it becomes a 1. The moment you divide by minus 4 like this, the moment you divide each and every term by negative 4, this will cancel. Minus 4 and minus 4 cancel. Then we have 1. We want to make that to be 1. We are not worried about all other coefficients later on. We are worried about that one for x squared. It must be 1, the part of x squared. All right, so this was going to be x squared. 3 divided by negative 4, it was going to give us negative 3 over 4x. 6 divided by negative 4, this was going to give us negative 3 over 2. That's equal to 0. So that's what we have. The coefficient of x squared is now a 1. So what are we going to do? We are going to need half the coefficient of x. We are talking about the coefficient of x. This is what you're going to need, this one. We are going to need half that coefficient of x, but being squared. What is the coefficient of x? That's over 4 like this. Then you square it. All right. So, guys, for this one, make sure that you go through the introduction so that we do not waste much time. So, half of minus 3 over 4 is minus 3 over 8 being squared. So, you can square this 4. All right. So, yeah, like I said in the introduction, as for me, I prefer using this stage. Yes, you can use this one, the 9 over 64. I'm not saying it's wrong. You can use that as it is, as long as you understand where it was taken from and the meaning of it there later on in terms of your factorization. So using the minus 3 over 8 squared, what we must subtract that from our normal equation that we are given. So this is what we are going to have: x squared minus 3 over 4x. Remember, this is where we are going to complete the square. So we're going to add. So you add that minus 3 over 4. So this is going to be plus minus 3 over 8 squared. Or the 9 over 64. It's your own. So you have added this to our expression. We must also subtract. Remember, it's add and subtract. So you also subtract that, the minus 3 over 8 squared. So this is what we have adjusted to our question, but it does not make sense because this gives us a 0, meaning to say we're just neutralizing our question. The rest is going to remain as it is, the minus 3 over 2 as it is, like this. So if you check, we haven't affected anything because this cancels this part. Is the same. We added, we subtracted at the same time. So it cancels. But the purpose of it is that we can factorize. So do not cancel, because what we need is formed here, which is a perfect. And this perfect square can simply be factorized by considering the first and the last term. Like I said on our introduction, this first term and this one. These are the ones that you consider, these ones. So that's the importance now of not simplifying so that you properly see those numbers. So, and the term. So this one, it's x, you take as it is. This one, it's minus 3 over 8. You take it as it is. Then you square that. You factorize that. First term and the last term of the quadratic expression, this one that we have formed. This is how you factorize a perfect square. The rest simplify. So we are going to simplify the minus, this part that is remaining. All right, so let us simplify this. That's right. Remember, we fixed our calculator. Let's get back to the normal. That's 8. Then press 2. All right, so there's a minus. Do not forget this. There's a negative there, so it's minus. Then open a bracket. We've got minus 3 over 8 squared. Minus 3 over 8 squared. Minus 3 over 2. All right, simplify this properly. That was going to give us minus 105 over 64. Right? So we are going to obtain minus 105 over 64. That's equal to 0. So we simplified, as you can see, it's one equation, but this equation is now subdivided into two parts. The first part, which needs you to factorize, and the second, we can solve this a perfect square that we have. We can see the 2 that we have as our exponent. So in order for us to remove this, we must introduce. So let's take this term or this number to the other side of the equation. 0.5 as it is. X minus 3 over 8 squared is equal to this. Introducing the square root for us to remove the 2 that we have, which is our perfect square. There was the square that we have there. So introduce the square root both sides. This was going to give us x minus 3 over 8. Remember, the square root neutralizes with the square that we're given there. So this was equal to, can we have the direct square for this one? The square root of 105, we do not know that one. So we're just going to leave it like that. Plus or minus the square root of 105. What about the square root of 64? We know this one. The square root of 64 is 8. The square root of 64, we know that one is 8. So that was what you're going to have, guys. So let's combine, taking the minus 3 over 8 to the other side of the equation. It was going to be positive 3 of 105 over 8, which we can see that, guys, the denominators are the same, combining the numerators together. Everything over the same denominator that you're given. So it is going to be 3 plus or minus the square root of 105, everything. This is exactly the part that we got from our quadratic formula for those who were using a positive, for those who used it as positive 4x squared, not the minus, but for those who used 4x squared, you're going to see that we're going to have the same part here of the square root. All right, so simplifying this from our calculator, the first part of a positive was going to give us 1,66. Another one was going to give us minus 0,91 to 2 decimal places. Remember your instruction. So using of the completing of the square method, we can see that it is a method which requires a lot of stages in the simplification. But if you know these stages, that's the way that you're supposed to have these stages, you know that you need to find half the coefficient of x square of x there, then you square it, you add and subtract that, factorize, and another part simplify, then from there you can solve for x. If you know these stages, guys, you can actually opt for completing of the square method. But if you are used to the quadratic formula, please use your quadratic formula and make sure that you perfect your quadratic formula. As you can see, guys, it can be just one and the same. 1.13, again, it is to solve for x. Having our equation that is under our sets, 3 square root of x minus 2 is equal to x. It was a 4-mark question. So that is what we had there, 1.13. You are given 3 into the square root of minus 2, which is equal to x. You're supposed to solve for x. Having the square root, you're supposed to remove this square root. I said that when you are to remove the square root, you're supposed to have a single term, which is the square root. But this part that we are having, guys, the number multiplying a square root does not affect that. Does not affect the square root. If I'm given x plus 3 like this one is called an expression. Adding or subtracting a certain number or a certain term from another term. makes it to be an expression. But the moment, guys, I take this expression, multiply it by a certain number that is like this, no matter this number that I'm having or this expression that I'm having, it makes this to be called a single term. We take it as a term. Yes, if we expand this, we're going to have an expression, but we just take it as a single term. It's a multiplication, same as a division. If it was x minus 3 over 2 like this, you just take it as a single term like that. Division and multiplication. But the moment you consider addition to say it is 3 which is added to x, these are now two different terms. A term, and this is now multiplied by a certain number, guys. It's now a single thing. So I want you to understand this concept, because this is exactly what you have. Instead of you dividing by 3, yes, you can do that to divide by, but you see that you later on you have to multiply by that. So instead of you to divide by 3, because it's a single term that you can see because of the multiplication that is there, introduce the power of 2. Raise everything to the power of 2. So you're going to raise this to the power of 2. You also raise this to the power of 2. There's no need for us to divide. Yes, we can do that. I'm not saying it's wrong. No. I'm not saying it's wrong, but there is no need. All right, so let's go, guys. 3 raised to the exponent of 2 was going to give us a 9. That's 3 squared. 3 times 3. So that's a 9. Remember the purpose of the square root and this square. Remember the purpose of raising to the exponent of was to remove the square root. But as you are removing this square root, the 3 is affected. It is raised to the power of 2. 3 is outside of the square root. That is why it's affected. But the square root raised to the power of 2, this one, with x minus 2, without the square root. The square root and the square neutralizes. Remember, it's a bracket. Everything is 2. Square root of x minus 2 to the power of 2, like this, everything. So the 3 is going to be a 9. The square root of this is just going to be removed, neutralized squared. X raised to the power of 2. So as we can see, guys, we formed a quadratic equation. The highest exponent there is a 2. Let's expand these brackets and see how it can be simplified further. 9 times negative 2, that's negative 18, which is equal to x squared. So forming our quadratic equation, like I said before, the format, ax code, the format on its own. So it is either we are going to take this to the other side, becomes a negative, then you divide by that negative later on, or you can take these terms to the other side of the equation. It is up to you. So if I was to take this 9x to the other side, we're going to obtain 0 is equal to x squared, the 9 negative, 18, this is minus 18, to the other side, it will be a positive. So that is how it is going to be like. Writing that a is equal to b, remember, it is the same thing as writing b is equal to a. So if 0 is equal to the whole of this, then what does it mean? It means the whole of this side is also equal to a 0. We can just write it that way. So instead, guys, we can just write our equation as x squared. That's minus 9x. Do not change anything. Just take as in is equal to. We're just saying this right-hand side is equal to the left-hand side. That is what we just expressed there. Nothing has changed. The only part that changes is when you are transferring to say, I need to transfer these ones from this to the other side. We are transferring terms. There we are not transferring terms. We're just saying these two, they're equal. So I can write 1 equal to another or 1 equal to another. There's a difference. So for those who need, for those who want to avoid this confusion of changing these terms, you can use the division concept. Avoid it by just having this, so that it will be minus x squared. X as it was going to be equal to 0. You can divide by that. That is what you could have actually worked out. X squared, positive, negative, positive. That's equal to 0. So as we can see, guys, same equation, but the different. But at the end, you are going to have the same equation. So that's it, guys. With this equation, let us try to actually solve our equation by factorization method. As you can see, factorization can be easier. The coefficient of x squared is 1. So you can just try our factorization here. Remember, one of the brackets, if it is a 1 like this, we're going to have x and vectors or the products of 18 But remember, these products must add up, guys, factors of 18. 18 as a number, this 18, positive 18. But if you add the two numbers, you must get a negative 9. Which numbers can we use? All right, thinking of 6 and 3, there's a possibility of having a 9. If we are to multiply 6 times 3, that's 18. You add, that's positive 9, not negative 9. So for us to obtain a negative 6 times negative 3, that's a positive 18. If we add negative 6 plus negative 3, that was going to give us a negative 9. So it's a trial and error. Try as many factors as you can see that will give you positive 18. But of all those factors, you need only one pair that when you add, you must get the middle term, the middle number there, which is the minus 9. And as we saw from these, it's minus 6 and a minus 3. So this is what you're going to have, minus 6, minus 3. So that 6 to the other side will give us a positive 6, or x was going to be positive 3. All right, the minus 3 to the other side. So these are the x values that we have obtained, and we need to test the values of x. Are they going to satisfy the equation that we are given in the original place that we had? If we are to substitute these x values, does it actually make sense? The left-hand side, is it going to be equal to the right-hand side? Remember, our equation was given, so here you just have to test. There was 3 square root of x minus 2 is equal to x. So let's start with the x being equal to 6. So it is going to be 3 square root of, in place of x, you substitute a 6. So that's 6 minus 2. Is it going to give us x, which is still what? A 6. Remember, we are substituting x, which is a 6. So if you were to simplify this, let us just take our left-hand side. So this is 3, the square root of 6 minus 2. All right, so as you can see, guys, you're obtaining a 6. The answers that you get exactly on your calculator, those are the ones that you use, not the plus or minus concept of for mathematical knowledge, but the calculator, how it expresses its answers. If the calculator cannot give you that answer, it means that cannot exist. But in this case, we've got 6. So 6 is actually equal to 6. So this is correct. So meaning to say the value of x satisfies our equation when x is 6. The left-hand side is equal to the right-hand side. So let's try another part. Our x value this time when it is equal to 3. So in place of x, we're going to substitute a 3. So this was 3 square root of x. So that's 3 minus 2 is equal to x. At that moment, it's supposed to be equal to what? A 3. Remember, you're substituting x, which is what? Which is 3. So let's test, guys, and see if we are going to obtain that. So in place of our x this time, I'm going to remove this and put a 3. All right, so this was going to give us a 3. So 3 is equal to a 3. So as you can see, the left-hand side is equal to the right-hand side. So this value of x is actually part of our solution also. So meaning to say this, in this question, both values were satisfying our solution. They are actually correct. So x can be a positive 6 or x can be a positive. So questions can be like that. You have to just keep on revising as much questions as you can. Then given this quadratic inequality, all right, let's see if we can just utilize this space. So given this quadratic inequality on 1.2, you are given 1.21, solve for x. So the first part was to solve for x in this quadratic inequality. All right, so let's consider our inequality, guys. That's 1.21. So you are given x squared minus x minus 20 is less than 0. And you're asked to solve this inequality. Remember solving inequalities. All right, this was actually just 3 marks. All right. Remember solving inequalities. I talked about this, guys, as a separate topic, solving quadratic inequalities from the number line concept, the use of the graphical method. That one is in your hands now. You are the one who is to choose. But in either way, whatever way that you're going to use, the first thing that you need is to determine what is referred to as the critical values. The critical values, these are the x values, the solutions that you obtain as if you're solving an an equation. So remember, if you're to solve an equation, guys, you're going to factorize. You can see that the coefficient of x squared there, that is a 1. So you're going to open two brackets. That's less than a 0 like this. All right. So since we have a 1, that means it's going to be easier for us because we're just going to have x and x here. Let's consider the products of negative 20. But these products must add up to this one, which is a minus. It's a minus what? That's a minus 1 that we are given there. There's a number there. It's a negative 1. So we actually need factors there. Two products, negative 20. So thinking of negative 4, between these, there is a possibility of getting a 1 because there's a negative. The one of these is supposed to be negative. So is it going to be negative 5? Is it going to be a negative 4? That's the question. Because we can see the possibility of a 1 there. But which one is going to give us a negative 1? All right, let us multiply these two. We get a negative 20, which is true. If we add these two, we're going to get a negative 1. This is exactly what we need. If we were to multiply these, we're going to get a negative 20, which is true. But if you add these two, you're going to get a positive 1. 5 plus minus 4. It was going to give you a positive 1. We need a negative 1, not a positive. So it must be from minus 4 and what? And from minus 5 and a plus 4. These are the ones that we need. So a minus 5 and a plus 4. So let us now have our critical values. Like for x, you're solving an equation. Just forget about this inequality for now. Let's say there's an equal to here. How are we going to solve? You're going to say x is equal to what? 5. X is equal to 5. The minus 4 to the other side is going to give us, this positive 4 to the other side is going to give us what? A negative 4. So x is 5, or x is equal to minus 4. Like I said, these need now is to obtain the exact solutions. That is where now your methods play a role. That's where your methods now play a role. Talking of the using of the table, using the number line, using the graphical, that's where they play a role. All right, so I'm not going to waste time. I'm just going to try explain the graphical. Remember, from your graphical method, we can see that from the x squared minus x minus 20, the coefficient there of x squared is 1. So that is our a is greater than 0. So you're going to have a smiley shape like this. That is the shape that we actually expect to have. So if we're going to expect to have such a shape, having two solutions at minus 4 and positive 5. So we can tell from the 0 minus 4 is on the left, positive 5 is on the right. All right, so that is just a sketch, guys. All right, so let's say this is minus 4, this is positive 5. The solutions that we're going to have are such that they are supposed to be less than 0. Meaning to say your function, in this case, if you are to consider this function, your f of x, we are saying f of x must be less than 0. Which region are we talking about when f of x is less than 0? If you remember clearly, I said this is the region in between there. Below the x-axis, you compare them with the x-axis. This is your x-axis. Along the x-axis, our f of x is equal to 0. So above, it is greater than 0. Below, it is less than 0. So if it is in between like this, below this, and these are values that are in between, I said your solution will be therefore written as x is greater than the minimum value, this one. This is your minimum value, which is minus 4. So x is greater than minus 4. X is greater. Remember, x is pointing minus 4. But the same x, this one, is supposed to be less than the bigger value, which is 5. So it is less than a 5. So that's it. Reading from x. X is bigger than minus 4, but x is less than 5. That is what it means from that interval that we're given. So that is your graphical method, guys. You have your solutions. If you're to use the number line, still it's one and the same thing. Remember your number line, like I said, you must test your solutions. As you have your number line, let's say you've got the minimum value there, which is -4. So let's just say this is where we have -4, and this is where we have our 5. You test your values in within these values of -4 going to the left side. These values compared to -4, they are less than. If how do you write these values in between, just like how we wrote the previous ones? X is greater than -4, but the same X compared to 5 is supposed to be this side of 5, going this right side of 5. What are they compared to 5? They're bigger than 5. They're greater than 5. 3 possible solutions. I'm not saying 3 solutions. I'm saying possible, meaning to say 1 or maybe 2 of these or maybe all of these can be our solution because they are possible solutions. So how are we going to obtain now the exact solution? By testing now. Each interval, you have to test it. So in testing, you can test using the first one that you have there. You can test using the second one where you're the brackets. That part of testing, guys, it's in your hands. All right? That part of testing, guys, is in your hands. So let's just, okay, use the first one. It's up to you. X squared minus x minus 20 is supposed to be less than 0. When we say less than 0, it means the number that you're going to get there is supposed to be a negative, less than 0. From 0, where do we go? -1, -2. Those are values less than 0. So our answer is supposed to give us a negative. If we take a value from that interval, you must get is correct. So you're supposed to choose, guys, which of these interval is correct. Let's start with -4. X is less than -4. Any value that is less than -4, we are talking of -5, -6, -7, -8. Pick any value of your choice that you want to represent as your X. Any of your choice. So in this case, I was going to pick a -5. I plug in this value in place of X. So this is going to be -5 squared minus, in place of X, I'm substituting what? -5. That's a -5 like this. -20. So we want to see, guys, are we going to get a positive or are we going to get a negative value? That is how we're testing. That is how we're testing this. Are we going to have this positive or are we going to have what? A negative value. All right. So let us see if we are going to have that value here. So we can properly see our values. So that was -5. So just going to test this one straight. All right. So you need a bracket there. -5. So that's -5 squared minus, open a bracket there, just gonna put a -5. So you pick any value, guys. I'm not saying use -5, use any. You can use -6, you can use -7, whatever that you want, but make sure that you substitute properly. All right, so if I substitute a -5, I'm going to obtain a positive 10. That's 10. Positive 10, I'm getting 10, positive. Is it a negative? No. Its answer is supposed to be less. If you substitute any x value, this is what you're told wrong. So any value of x is less than -4 is wrong. -6, -7, -8, -9, whatever value that you think about there. If you use a value there and you're obtaining a negative value, guys, that must be wrong. So let me know, guys, if you have got any value that is giving you a negative in that interval. If you're obtaining that, let me know so that we can talk about that. Let's move on to the second interval. In between -4 to +5. In between 1, 2, 3, up to 4. Guys, test any of these, any one value. Substitute it into this and see if you're going to get a negative. So just for the sake of time, that was just gonna give us a 0 squared minus a 0 minus a 20, a -20. We are obtaining a negative. Guys, use any value that you think of there. As long it is in within these -3 and 4, choose any one of your choice. You're going to see that your answer will be a negative. I'm not saying a -20, but it is going to give you a negative. It can be -100, it can be -10. I don't know. What are you going to get depending with the value that you have substituted? But the answer is going to be a negative. This is exactly what we want. Less than 0. That's a negative. So this is exactly the interval that we want. It satisfies exactly what we need in between this interval that we are given, -4 to 5. This is the exact interval that we need. So we're going to take that. Remember, you're testing each and every value that you're given. Each and every interval. We started with this to the mid one, greater than 5. All values that are bigger than, and so on and so on. Just pick any value of your choice. Substitute that, like a 6. Just substitute, instead of taking bigger values, you can just choose a 6 there. So 6 squared minus 6 minus a 20, like this, minus a 20. What are we going to get? Are we going to have a positive or are we going to have a negative? That is what we are testing. The sign is already given there. Less than 0. So that is what you're testing. All right. So let's just substitute in place of this x. I'm just going to remove, then put a 6. Do the same thing on this one. Going to remove this, put a 6. So as you can see, we're getting positive 10. It's a positive, not a negative. Try any value, guys. You can put this and put it. You can remove this and put a 10. Okay. Let's substitute and put a 10. Any value, guys, which is bigger than 5, it is giving us a positive. Any value bigger than 5, you can try a 7, whatever, as long it is bigger than 5. The answers are positive. As you can see, 22. These values, they are positive. They are all positive. We are not going to get a negative in this interval. We are not going to get a negative answer. So it means this interval is actually wrong because the interval that we need says it must be less than 0. So that's your number line method, guys. For those who are using the number line, you have to test. But I explain this, guys. I just hope in exam you're not going to waste much time because you know what you're doing here is just because of the issue of revision so that we all understand what is happening here. But we're not even supposed to spend all this time because you know, okay, I'm just going to have three solutions. From those 3 solutions, I have to pick one, and test which one is going to give us the exact solution, which one is going to satisfy our solution. So that this one is the one. So x is greater than -4, but less than 5. All right, as we head from the previous one, it also gave us the same solution if you're using the graphical method, if you're dealing with the graph. All right, then we're given on 1.22, hence or otherwise determine the sum of all integers. The sum of all integers. The sum means what? When you solved your inequality, this is what you got. X is greater than -4, but less than 5. Meaning to say we have got a -4 here and a 5. Our number line is supposed to be like this at 4 and 5. Because we are not considering this -4. It's not part of our solution. The solutions are integers that are greater than -4, talking of -3, -2, and so these are the integers. So they are saying in between those integers, find their sum from the -3 up to what? Up to 4. So let me just list because they represent x. So our integers, which are representing x, 1, 2 integers that are within the interval that we are given. X is greater than, there is no equal to here. So -4 is excluded. If there was an equal to, you were going to use the -4, but it's not there. It means it's excluded. It's not part of your solution. It's not there. So these are the integers that we have in this interval, but they do not want you to have these integers. No, they say find the sum. So the sum, you must add these integers that you are given. That is the sum. You add -3 plus -2 plus -1 plus, you are adding. So you can just use your calculator, guys. Add all these numbers together. The sum was going to give you a 4. If you add properly, you're going to obtain a 4. Just like that. They say the sum. So answer the question. Do not say it's just an inequality that I'm given. Yes, it's an inequality. What are they saying? in that same inequality that you are used to. You have to be very careful in answering of your questions. All right, so that was it, guys. Solving of this inequality. Then just all right. On 1.3, we are given to solve simultaneously for x and y, given these two equations. The first one, we are given 4x plus y is equal to 7. So remember, guys, when working quadratic, this other part where you have got this part 2, that's a quadratic. I said from the linear equation, make x or y the subject, the one that is easier for you. Which one is easier? You can make y the subject by taking 4x to the other side. The moment you take 4x to the other side, you have made y the subject. So we can make that as our equation. So meaning to say, instead, we are going to have our equation as y is equal to, take the 4x to the other side, it is going to be negative. So that's 7 minus 4x. We have formed another equation. So if you had equation 1, equation 2, we're going to call this equation 3 into equation 2. Equation 2 is that 3x squared plus 2xy is equal to y squared. In place of y, we are going to substitute this. So meaning to say our equation now is going to be given as 3. There's a y here. There's a 2. Y. That's 7. The y there. That's 7 minus 4x. But this must be an equation which only has x, one unknown value. One unknown value. All right, so let us expand, guys. Expansion of bracket we need here is to expand our brackets by 2x. So the 3x squared is already out there. So it's going to be 3x squared, 2x and 7. All right, 2x and minus squared. Remember x and x, that's your expansion of 2 times, which is the first squared minus 2 times the first and last, plus the last squared. So your a squared, this is your a, you square it, 7 squared. 7 squared, that is 49, minus 2, your b that you see there. So you're going to multiply minus 2 times 7 times 4x. Minus 2 times 7 times, which was going to give you minus 56. So that's my squared, this one, squared. That's squared. So these are your, but if you do not understand that, expand properly, guys. There are 2 brackets that you need there. Expand properly. Collect your left hand. Still, you're going to have the same answers at the end. All right, so this is where we are. We have got part that we need to just simplify. The left-hand side, we can see that we've got quadratic. This part, let's just collect our leg terms. 3 minus 8, that's minus 5. So we've got minus 5x squared plus 14x, which is equal to 49 minus 56x plus 16x squared. We have a quadratic equation because the highest exponent through there. So we have to collect our terms to one side of the equation. Remember, the concept of the equation is that one side is supposed to be equal to 0 if it is a quadratic. So it is up to you how you're going to take your these ones to the other. Is x squared to this. You're going to add 5x squared is going to be 12. You do the same thing. The 14x is a positive. To this other side, it becomes a negative. So it was a positive. So here it is going to be a negative. So that's minus 56, 17. So that's on the right-hand side. So this one is not going to change. So that's our quadratic equation, guys, which, like I said, equal to the left. This first, if a, you can even just rewrite the x plus, I have the quadratic formula factorization, but you can also try 2 pools of 7. So meaning to say 7 is the highest common factor. So divide by 7. All right. 21 divided by 7, that's 3. So you're going to have 3x squared negative 10x. 49 divided by 7, that's a 7. So reducing these, it just helps you to work with a simpler equation. Not to say it is going to change or affect your answers, even if you do not divide, guys. Especially if you are using the quadratic formula to solve. There is no need for you to reduce. But for those ones who will be using factorization, it is best for you to do reduce by the highest common factor throughout your equation up to the end. You divide by that. It's an equation. You're allowed to divide. So using factorization, the quadratic formula is something that is of the factor method. I don't know which one I'm going to use. We know brackets represent a cheat method. They do not change the way that I say x is factorized there is going to differ. All right, but using the cheat method, I said we can just take the 3, remove this 3, because what you want is to have a 1 that you used to. So you take out this 3, multiply to the last term. So that is going to be, you remove it totally, it's no longer there. This one is no longer, you remove it total. So it's now x squared minus 10x. Remember, you're multiplying it to the last term here, 7 times 3, which is going to give us 21. Then you factorize as the normal way that you are used to when the coefficient of x squared is a 1. We know that we're going to have x here, we're going to have x here. Then focusing on the factors or the products of what? Positive 21, which will give us a negative 10. So definitely that's negative 3, negative 7 and negative 3. If you multiply this, you get a positive 21. If you add, you get a negative 10. So these are the ones that we need, guys. Negative 7 and a negative 3. But we cannot say this is our final answer because we factorized something which is actually not part of our question. That's why we're calling the cheat. We are going to cheat this. Take back the 3 in place of x. That is how we cheat our question now. In place of x, we bring back the 3. So we're going to bring the 3, we bring back the 3. In every bracket, consider every bracket. Is there anything common in any of these two brackets? The first one, we do not have anything common. The second one, 3 is common. We can factor out the 3, which is common. So it means this was going to be 3x minus 7. We factor out the 3, this one, which is common. So factor out this 3, this is going to remain as x. 3x divided by 3 is going to be x. Minus 3 divided by 3, that's a minus 1. So remember, guys, I said anything that you factor out will totally be cancelled, not part of your question. So the answer to our brackets are these two brackets that we are seeing here. Minus 7, another one x minus 1. Guys, the way that you factorize, consider what you have done, what is it, especially for exam condition, guys, use the best method. But at the end, you are going to have these two brackets. Whether you've used whatever sort of factorization, any shortcut. I know that depending with your teacher, you've been taught different ways there. Different ways. Shortcuts. Longer ways. Guys, whatever that you have been, this is what you're going to have at the end. So with these two brackets, let us solve for x. One of these must be equal to 0, so maybe equal to 0, or this other bracket of that gives us the value of x. Minus 7 divided by the 3. So that's minus 7 over 3. The minus 1 to the other side will give us a positive. So these are the x values. Our x was going to be positive 7 over 3, or x is equal to 1. But as we are seeing that this was a simultaneous equation where we are solving for x and for y at the same time. So using our equation 3 where we made y to be the subject, we can easily substitute in that part so that we obtain the y values from there. We can easily substitute in that equation because remember you're saying from equation 3, y is equal to 7 minus 4x. So you can easily substitute there. In place of x, let's take the x value as 7 over 3. So y is equal to 7 minus 4 into x. Our x is 7 over 3. That was going to give us the y value. So this one is just you guys and your calculator. Straight substitution. That's a 7 minus 4 into 7 over 3 like this. A straight substitution. So that was going to give us minus 7 over 3. All right. So for this value, you're going to over 3. So that's a minus y value. Okay. When x is y minus 4, 7 minus 4, that is what you have. So e minus 7 over 3. Y is equal to 3. So that is how we can conclude that at the end, say if one of these, if this one is this, then the other one is going to be like this. So solving of this, make sure that you choose an equation which is easier for you to make the subject. Definitely, that's a linear equation, the one that you'll be given. You'll be given one a linear, another one a quadratic. Never try to work out from the quadratic. You need to make x the subject from a quadratic, or you need to make y the subject from a quadratic. Never try that. Use the linear equation. And on the linear equation, also do not use do not work with the difficult part where you need to make x the subject. Look at the x there, you have to divide by 4. Whatever that you're going to have, it was going to be 4x is 7 minus y. Then you have to divide by 4, divide by 4. The moment that you're substituting where x is, you're substituting a fraction. Most of you, it is difficult. Most of you find it challenging to work with fractions. So avoid that. If it is avoidable, avoid. How do you avoid that? Look for another letter. Can I make y the subject? Yes, y can be. You can work from there. All right, so that was it, guys. Let us consider equation R. So as you were solving the quadratic equation, this is the stage that you remember your quadratic formula, x root of b squared. You were solving, then you substituted. This is what we got. Then they're saying calculate the value or values of k for which the roots are equal. If we are talking of equal roots, we do understand from the delta, remember your delta or your discriminant, this one, the b squared minus 4ac. Remember, that's your delta that you're talking about. For equal roots, it is supposed to be equal to z. It must be exactly equal. This one, b squared minus 4ac is the part that is under the square root. So if it is this one that we are talking about as our delta, which is our discriminant, what is it? How is it represented on the other side here? How is it? Because we can see it here. We can see it here. This is the one that we have. That's our b squared minus 4ac. That's our delta, this one. So instead of us writing b squared minus 4ac or this delta, this one, we are substituting exactly what is representing that according to our question here. What is that delta? It's 13 minus 2k. That is what you're given. It must be equal to 0. So what have you formed? An equation. You formed an equation. With this, you can solve for k. It is exactly equal. For us to have equal roots, it must be exactly, there's no greater than, there's no less than. It's an equation, this one. So what will be the value of k? So that will be minus 2k is equal to 13. To the other side will give us a negative 13. So there you can choose any one that you want to transpose or that you want to take to the other side of the equation. Then simply divide by negative 2. So our k was going to be positive 13 over 2, or you can divide that one or have it as a mixed fraction. It's up to you guys. If it is a mixed fraction as it is like this, that was up to you for 2 marks. You can just leave it as 13 over 2. All right, so that is it, guys. You have to be very, very careful in attempting your questions. 1.5 you're given. This part is equal. Calculate the values of p for which the roots of the equation are non-real. We are still back to the concept of our nature of roots. But they are saying this is non-real, and we do understand if the roots are called non-real, our delta is supposed to be less than 0. We're talking of negative values. Or we are simply talking of the b squared minus 4ac must be less than, it does not, we do not have a solution at all. So meaning to say under the square root, we must have a negative value that is to be less than 0. But how can we see that b squared? Because look at our question, guys. X plus 5 squared is equal to 1 minus p squared. Look at our question. We cannot actually see which one is our b, which one is our a, which one is our c. So we have to expand the brackets. Remember, I talked about this, guys, expansion of brackets. If you're given a square like this, a plus b squared is equal to a squared plus 2ab plus b squared. Or you can just have 2 brackets, x plus 5 into x plus 5. So after expand plus 25, I'm just going to rush on this one. All right, so this is equal to 1 minus p squared. So after expanding, we can see that it's a constant. Where you do not have x, every part where x is not there, where you cannot see an x, it becomes a constant. So if we do understand the concept of a quadratic equation, for us to use the discriminant concept or the delta concept, we must have the basics of squared plus bx plus c is supposed to be equal to 0, where we can properly see which one is our a, which one is our b, which is our c. So we have to take this constant to the other side as it is. So that was going to be x squared plus 10x plus 25. We take our constant to the other side, 1 to the other side, it becomes a negative. So that's negative 1 minus p squared. So that one you can actually subtract, because we can see what we have. You can actually subtract, or you can just leave it like that. The minus p squared to the other side, it's minus, becomes a positive. That's equal to 0 like this. What we need is to have this part, guys. Here, 25 minus this, or you can just have it with as it is. You can just leave it like that. It is up to you. You can simplify that. So that was going to be x squared. Let me just write it here, guys. 25 minus 1 is going to be 24. So that will be plus 24. All right. You have taken this. So it'll be plus 24. The p squared, guys, is all right. So that was plus p squared. All right. This is where we are. So we can use that as 25 minus 1 plus p squared. I'm not saying it's wrong, but you can simplify. Okay. Having this, we can now see the concept of the equation to say the coefficient of x squared. That's the one. That's our a. So we can see that our a is 1 from there. The coefficient of x, that's our b. So what is the coefficient of x? What is affecting x here? That's our b, the coefficient of x. So b is positive 10. What about c, which is a constant where we do not have x? The whole of this part here, we do not have x here. This one, 24 plus p squared, or the 25 minus 1 plus p squared, depending with the way that you wrote it. It's a constant. We do not have x there. So it becomes a constant. So as you have your quadratic equation in a manner that you are used to, where you see your a, your b, and your c, or as to have non-real roots, to say the roots, they do not exist at all, our delta must be less than 0. So let's find our delta. Okay. Let's determine our delta in that case. So our delta, remember, that is b squared minus 4ac. So we're going to simply have 10 squared minus 4 times a, which is 1 times c. Since this is an expression, so we're just going to have to open the bracket there. That's 24 plus p squared. So let's simplify 10 squared, that is 100. 4 times 1, this one you're just going to multiply. Minus 4 times 1, guys, that's a minus 4. Then we can expand minus 4. We multiply with the 24 that we are given. All right, so that is this part we're going to multiply. That's a negative 4 and a 24. That was going to give us 96, negative 96, negative 4, and the p squared. All right, 100 minus 96, that's 4. So we're going to have 4 minus 4p squared like this. This is our delta, 4 minus 4p squared. That's our delta. But we are saying this, it is supposed to be less than 0. Calculate the values of p for which the roots of this equation are non-real, meaning to say our delta is supposed to be less than 0 for us to have non-real roots. So we are going to solve this inequality now to say this delta, if it is less than 0, what does it mean? Our equation is this equation, which now changes this expression. It is now 4 minus 4p squared. That is less than 0. An inequality now that you're supposed to solve. Now you're supposed to solve an inequality. So solving this inequality, it depends with what the way that you're going to have, but as we do know, your critical values using of the graphical method, that one is up to you. All right, so I'm just going to factorize. As you can see, there's a difference of 2 squares. So you're going to have our difference of two squares, the square root of 4. You can also factor out this 4, as we can see that 4 here is common. Then you have your difference of two squares. From there, guys, it's up to you. But you can simply use that. That's 2 minus 2p. This one was going to be 2 plus 2p. So if you solve for p, guys, we're going to have same answers. What I'm simply saying is that you could have here, it's less than 0 like this. An inequality can be solved as an equation. You can also divide like here by 4. You can reduce it. So it's going to be 1 minus p squared is less than 0 like this. Meaning to say, on your difference of two squares, you're going to have your two brackets like this. That's 1 minus p, 1 plus p. You solve for these two brackets. All right. 1 minus p is equal to 0. 1 plus p is equal. It's now an equation now when you're solving for the critical values. So meaning to say, if we are to take the minus p to the other, so 1 is equal to p, or simply means that p is equal to 1. If we say 1 is equal to p, that means our p is going to give us a negative 1. So there are two possible values. You can also do that even from this side. If you wanted this, you can 2 plus 2p to the other side, there it becomes 2p. You then divide by what? By 2. So p is equal to 1. You do the same thing here too. You're going to take the 2 to the other side. So 2p is equal to minus 2. You divide by 2 by 2. So p was going to give you a negative 1. So determining of the critical values, guys, that one is in your hands. Oh, that one is in your hands. It's in your hands. So as you can see that our p is going to be 1 or our p is going to be negative 1, depending with the way that you understand. You can, I don't know the way that you're going to solve it, but you're going to have these two possible values. Now you also use that number line, the graphical method, depending with what you're having. Using the graphical method, we can see that the coefficient of here, the part of p squared, this is just like when you're considering the coefficient of x. It's a negative that we are seeing, right? Remember, it determines the shape. So a negative, that's a set shape. If it is a positive, a smiley shape. So in this case, we are having a negative. So meaning to say, we are going to have a set shape like this one, as we do understand that negative 1 and positive 1, this can be negative 1, this can be positive 1. So which region are we talking about below? I mean, that is less than 0. That is below what? The x-axis, if we are considering the x-axis, below that. So we're talking of these solutions. Below, not above. Above, it must be greater than 0. There is less, that must be less than this value, minus 1. So therefore, or our p must be greater than, going to this side, 1, 2, 3, and so on. Our p is supposed to start of what? The real terms or the real numbers that you can have. So guys, you see, they want you to use the knowledge that you have before, that all those basics. So I just hope guys, as you are revising, you're gonna utilize this knowledge to answer different questions. Know the question. What is it all about? The question. So if we are to consider the second question, we are given to simplify fully without using a calculator. Your answer must be free of negative exponents. So take note. Yes, you're being told without using a calculator, but also take note of the instruction thereafter. Your answer must be free of negative exponents, meaning to say you are not supposed to have any negative exponent. And irrational denominators, meaning to say your denominators are not supposed to be irrational, like what we are seeing there, square root of 3, square root of 6. Those are irrational numbers. So let us consider, guys. First part with this is 2.11, that is 64 to the exponent of minus 2 over 3 for 3 marks. Let's see how you're supposed to attempt this question. If we are to consider the exponents, try by all means to work with prime numbers. prime numbers. Talking of prime numbers, we're talking of numbers such as 2, 3, 5, 7. These are prime numbers and so on. Try to express the given number as a prime number raised to a certain exponent. So the question is, are we going to use 2? Are we going to use 3? Are we going to use 5? Are we going to use 7? Which one of these? So 64, guys, is related to 2. We cannot use 3. 3 to the exponent of what? To give us a 64. We cannot find that. It is 5 to the x. We cannot have, at least you have that basic idea as you are simplifying. So using 2, you can even, if you do not know the exact exponent, but just knowing that I'm working with a 2, it can help you because you can even try. It is 2 to the exponent of 4. You try, you see, okay, this is not. You move on, 2 to the exponent of a 5. You're trying. This is 32. You move on, 2 to the exponent of a 6. You can see that you have your 64. At least know the best. Not to say you are using the best of 3, you're trying the best of 3. You cannot even get that value. It is impossible. But if you're using the best of 2, we saw that 2 to the exponent of 6 is 64. 2 is a prime number. So that is it, guys. So 2 is the best for us to apply there. As we saw, that is 2 to the exponent of a 6. Representing 64, but already there is an exponent that we are given of minus 2 over 3. Already we have this exponent. So now it's a condition of an exponent to an exponent, exponent to an exponent. How do you simplify x to the exponent of a to the exponent of b? Remember, you multiply the exponents, a times b. So we're going to multiply these numbers. 6 times negative 2 over 3. Can you even use a calculator, guys? So you just have to multiply 6 times negative 2 over a 3. So that was going to give us a negative 4. All right. So meaning to say that's 2 to the exponent of a negative 4. How do we remove a negative? If we are given x to the exponent of negative n, we know this is 1 over x to the exponent of n. To remove a negative, that's 1 over. Remember, your answer must be free of negative exponents. We do not need a negative exponent. So that's 1 over 2 to the exponent of 4, which is simply 1 over 2 to the exponent of 4. That's a 16. So it was going to give us 1 over 16 at the end. All right, so for 3 marks, guys, we can see that can have those stages. They're actually important for you to indicate those stages. On 2.12, we're also given an exponent to work with, 3 to the exponent of 2n plus 2 minus 9 to the exponent of n minus 1, everything over 2 times 3 to the exponent of 2n plus 1. So remember, if you're given expressions, if you're having expressions on the exponents, just target for a common exponent, for a common base and is it a certain number like 3 to the exponent of n? Is it 3 to the exponent of 2n? It must be common. So you can see that we've got 3 to the exponent of 2n there, 3 to the exponent of 2n, but we do not have it here. There's a 9. So what can we do with this 9? What can we do with this 9? Let us change it to a 3. So it is going to be 3 to the exponent of 2n plus 2, this first part, minus 9 is same as 3 to the exponent of 2. That's 9. But what about this one? Because there is already n minus 1 that we're given. So we're going to multiply. So that's 3. That's 2 times n, which is 2n. 2 times negative 1, which is minus 2. So that is what you're going to have at the end. 3 to the exponent of 2 raised to n minus 1. You multiply by 2. All right, the other part, there's nothing that we can do. It's already in simplest form. So that's 2 times 3 to the exponent of 2n plus 1. Then from there, we can factor out that common term, which is common from the numerator, 3 to the exponent of 2n. So this is what we are having here, the 3 to the exponent of 2n. This is 3 to the exponent of 2n. You have to focus on this. You have to focus on that part. So if we factor out the 3 to the exponent of 2n, it's under the same base of 3. So it's just going to remain with 3 raised to the exponent of 2. So it is going to be 3 to the exponent of 2 minus, you factored out here. So what are you going to remain with? 3 to the exponent of minus 2. So this is what you're going to have. And the exponent of n is also there. We have to focus also with that one, because we can see it here, 3 to the exponent of n. These 3 are going to have 3 to the exponent of 2n. What we're going to have at the end. So this was going to remain, we're going to remain with 3 raised to the exponent. Remember, there's an exponent there. So 3 will be affected by its exponent like this. So this is what you're going to have at the end. Now let's simplify, because that we can cancel because it's under a multiplication. So these two can be divided. We can cancel these two. Now we've got something that we can simplify. 3 to the exponent of 2 minus 2, that's 1 over 9. Everything over 2 times 3 to the exponent of 1. 3, guys, this is just a 3. 3 times. They say do not use a calculator, guys. But as you are simplifying some of these, you can just use a calculator to simplify those terms, like 9 minus 1 over 9. You can just use a calculator. The 9 minus 1 over a 9 like this. That's 80 over 9. So the numerator on its own, we're simplifying this part of it. So it is just like this, 80 over 9 like this, divided to a 6. That is what it means. Divided to the 6. Dividing, you introduce a multiplication. So 1 over 6 like this. The moment you introduce a multiplication, you invert the second fraction. Calculator 80 over 9 times 1 over 6. Some of these guys, you can just use a calculator. No one is going to even know that you've used a calculator there. That's 40 over what? 40 over 27. So this is what you're going to have at the end. So guys, let us just try to work out as many questions as we can. We can see that these questions can be a repetition, but how do they repeat? How are they given? It's all about the practice. Practice as more questions. You will see they try to ask differently, but just one and the same thing. 2.13, you are given. Again, it was to simplify. And this time we have got the seds. That is 3 minus the square root of 3 raised to the power of 2 like this. Everything over the square root of 3 times the square root, with the way that you're going to simplify, guys. You can see that the numerator, we have to expand there. We have to expand. Remember, I talked about this earlier on the part of when you're given a square like this from your algebra, your grade 10 mathematics, a minus b squared. This is a squared minus 2ab plus b squared. Yes, you can have your two brackets, expand them, it's fine. This is 3. This is your b. It means your a, which is 3. So we know that. 3 squared is 9. So minus 2ab. It means a is 3. Our b is what? The square root. So that is the 6 square root of plus b squared. Simply neutralize and just get it. Identities under our square root of 3, you multiply everything. 3 times minus 3 square root of 3. Multiplying 3, so it's going root 3 and minus 3 times square root of 3, that's a 3. So give you a minus 6, 9, and 3. Collecting those like terms of brackets is in your hands. It is in your hands. All right, there we can have this. We can expand. Have it as a single term, it's fine. You can just expand. Square root of a, multiply this. So that will be the square root of 3 times 6, which is 18. So collecting the like terms, which are the numbers only, the 3 and the 9 and the 3, that was going to give us a 12. So we're going to add 9 plus 3, which is 12. So we've got 12 minus 6 square root of 3. All right, so that's minus 6 square root of 3, everything over the square root of 18. Remember, we are told that the denominator is not supposed to have anything rational there. So you're supposed to have irrational denominators in that case. All right. So in as much as you are simplifying, you are supposed to get rid of the irrational denominators. So let us go back and see if you have to consider. We've got square root of 18, which is actually an irrational. The square root of 18, we cannot simplify this. So this is irrational. So you have to rationalize our denominator so that we are having a rational. Remember, we need a rational term here. So rationalizing the denominator, let us multiply by the square root of 18 over the square root of 18. That is for us to rationalize the denominator, as we understand that the square root of a, more than this condition, 18 and 18, the square root of 18 and square root of 18 will just give us an 18. What we need is to make sure that the denominator there is a rational term. So let us see what we're going to have. It's going to affect 10 and 12. That is going. Then we move on here. That is minus 6 square root of 3 and square root of 18. So it's going to be like this, 18. So as you can see, these ones are under the square root. They'll mark them as they are, 3 and 18. 6 is not a square root of 54. So 3 times 18 was going to give us a 54. Everything over what? Square root of 18 and square root of 18. Like I said, square root of a times square root of a is a. So square root of 18 and square root of 18 was going to give us 18. This is where you are. So application is important, that application. So in the simplification, guys, at this stage, I want you to be very, very careful. For 54 that we are seeing here, they are not in simplest form. Yes, these are sets, and we have simplified is a rational term now. It is no longer irrational. It is no longer irrational in simplest form. So on simplifying this, you can use any other way that you can use to simplify. But guys, at this stage, even if you use your calculator, please bear in mind, these ones, I can even know it by head. This one, I get two numbers there to obtain 18, which is the 3 square root of 2. So if I know this one by head and someone who has just used the calculator, there's no difference at this stage. So do not trouble yourself at this stage. Say, how am I going to simplify square root of 18? I don't even know this one. Use your calculator if you do not know this one. At this stage, you can even use your calculator. What is the square root of 18? Okay? The square root of 18, 3 square root of 2, as we saw. So take note, there was a 12 before, so you have to simplify this. This is 12 times the square root of 18 that we got, which is 3 square root of 2. All right? Minus 6. You do the same thing, square root of 54. If you know that one, guys, you can simplify. 9 times 6 gives us what? 54. What is the square root of 9 is 3. So it's going to be 3 square root of 6. But if I do not know this, guys, the calculator is there. Square root of 54. That will be 3 square root of 6. So that is what you're going to have. In place of the square root of 54, we are going to have what? 3 square root of 6. So this is where we are. Everything is over. See, because we've got the part that we simplified, square root of 2. The square root of 54 now simplified to 3 square root of 6. So you can even multiply these numbers outside. 12 times 3 root of 2, 3, that is 18. So we've got a over 18. A minus b over c can be written as a over c minus b over c, provided that you have separated each term to the denominator. A over c, also b is over c. For you to separate this fraction, it is when you can write each term divided by 18. 36 square root of 3 of 2, this one, you divide it to 18. You also 6 over 80. This one is allowed as long you separate it this way. Divide 18 to, so that's 2 square root of 2 minus 8, which is square root of 6. So this is what you're going to have in simplest form. In simplest form, it is not just about simplifying, just, okay, I have the conditions, but also try to simplify your question to something that is best in your simplification, guys, as you can see. All right, so this is what you're supposed to get. This is how questions can be given. All right, x, so for x. Okay, so let's see 2.21, we are getting x root of 32, which is equal to 128. How can the x root of 32 be equal to 128? What is that x that we are talking about? What is that x? We do understand that, let's say we're given the cube root. Let's just say the cube root of x. We know this is x raised to the exponent of a third. The nth root of x, this is x raised to the exponent of 1 over n. So the number inside of the square root can be taken to be a fraction 1 over that number. So same as this x that we are given, it can be written as 32. exponent, it will be 1 over x, which is equal to 128. Now there's something that is coming to light as we have this as an exponent, unlike when it was written like this. Why am I saying we've got some light there? Because in the exponents, if the denominators, if these bases are the same, 3 to the exponent of x is equal to 3 to the exponent of 2, we can simply say x is equal to 2. It is because of the bases which are the same. So is that possible for us to have these two numbers in the same base, 32 and 128? Remember I said whenever you need the same base, you look for a prime number and it must be the simplest. 2, 3, 5, 7, 11, 3. These are the prime numbers. So which one can we use in place of 32 and 128? Which is common? Is it 2? Is it 3? Is it 5? So the common prime number there, guys, is a 2. 32 can be written in the base of 2 as 2 to the exponent of 5. Take note. It can be written as 2 to the exponent of 5. This 32 that we are seeing can be written as 2 to the exponent of 5 raised to the exponent of 1 over x, which is equal to 128 in the same base of 2. It is 2 to the exponent of a 7. So now we've got exponent. Remember, I talked about this before. You just have to multiply 5 times 1 over x. This is same as over 1. So 5 times 1 is 5. 1 times x is x. So it is going to be 2, which is 2 to the exponent of 7. So having these in the same base, it tells us that the exponents also are the same. Same bases, that's automatically to tell us that the x, we can say 5 over x is equal to 7. Because of what? This part of the bases, they're the same. So in that case, 5 over x is equal to a 7. So you can solve for x. This is just a linear equation where you need to just cross multiply to remove the fraction. So it's going to be x times 7, which is 7x. Is the value of x we can divide by 7 both sides. So that means x was going to give us what? 5 over that. We are going to work out as substitute this. You must get that same. All right, let's just put this one. That's this one. So inside, you're going to put 5 over 7. Remember, our x is what? 5 over 7. So I'm going to put 5 over 7. All right, sorry. 5 over 7 like this. Then here, I'm going to put 32. If I simplify this, I'm supposed to get 128. That is what it means. So, and exactly, this is what we get, 128, meaning to say we are actually correct. All right, so let's move on to another one. Again, it is a solve for x, and you're given this time 2.22x to the exponent of 1 over 2 minus 3x to the exponent of 1 over 4 minus 10 is equal to 0 like this. So this is a disguised quadratic equation, a quadratic equation which is being disguised. They can do that. They disguise that normal quadratic equation that we are used to. How? Oh, you just have to check between these two, which one is the smallest exponent? 1 over 2, 1 over 4. Which one is the smallest? 1 over 4 is smaller. 1 over 4 is less than 1 over 2 in terms of the exponents. 1 over 4 is less than 1 over 2. So you write this in terms of the smallest exponent, in terms of what? 1 over 4. This, the one that has got the smallest exponent, this one. So you're going to write, you're going to rewrite in terms of x to the exponent of what? 1 over 4. So what am I trying to say? We are going to rewrite these guys as the x to the exponent of 1 over 2 as x to the exponent of 1 over 4. So it is going to be like this. X to the exponent of 1 over 4 like this. But we must raise it to a certain exponent here so that it gives us the same 1 over 2 that we see there. What we just need, guys, is to rearrange, to have this, to have it in terms of the smallest exponent. And this is exactly what we have. But the moment we change this, we are not supposed to change our question. Our question is supposed to remain as it was. So which number are we supposed to use here so that it gives us back the 1 over 2, this one? So it is going to be 1 over 4. 1 over 4 times what? Times a 2. 1 over 4 times a 2, that's 1 over 2. How can I simply know this number? It's like an equation, guys. It's 1 over 4 times what? So that I'm going to divide by what? 1 over 4 by 1 over 4 both sides. Then I have the number that I need. So it's 1 over 2 divided by 1 over 4, which is going to give us what? A 2. Oh, by just side, by looking into, you can see this, guys, by just looking into the question. Because 1 over 4 times 2 is what? It's 1 over 2. We do not want to change our question, but we want to write it as this term raised to the smaller exponent. Only that way. Only that way. As you can see, guys, if we are to rewrite with that, we can solve this because it's now a normal quadratic equation because you can see the highest exponent is 2. But if you cannot see that, introduce another letter of your choice so that same 3 to the x1. Introduce your equation. So I can just introduce k there. All right? So let k be equal to x to the exponent of 1 over 4. If I let k to represent x to the exponent, but that is that's k squared a minus equal to 0. As you can see, guys, we are used to, we can solve this. But let's just get to what we are used to. So let's solve. It's a normal quadratic equation. The highest exponent there is 2. That is to make it a quadratic. All right? Here, as to we are going to have k 10. Which constants are we going to use? The factors that we multiply to get negative 10. But if we add, you must get a negative 3. So there's a 5 and 2 there that is just somehow there. 5 and 2 is somehow. But how are you going to write it? We need negative 10. So is it going to be negative 5 or is it going to be a negative 2? If we multiply here, we get a negative 10. Add, are we going to get a negative 3? Yes, the first one gives us negative 3. This one is going to give us a positive 3, which makes it to be totally out. So we need minus 5 and a positive 2. Minus 5 and a positive 2. So that's minus 5 and a positive. Minus 2 to the other side. And we are saying k can be 5, k can be minus 2. But our equation, was it in terms of k? No. Our equation, it was x. We are not solving for k, we are solving for x. Where is the x? Where is it that we lost that x and had a k? It is at this stage when we introduced the k in place of x to the exponent of 1 over 4. So let's bring that now and say, if truly that k is equal to x to the exponent of 1 over 4, is it that in this condition, x to the exponent of 1 over 4, it must be equal to the k that we got. The first k is 5. X to the exponent of 1 over 4 is equal to kx values. All right? So remember, guys, to remove this 1 over 4, we need the reciprocal or the inverse of 1 over 4 raised to the exponent of 4. So x was going to be 5 to the exponent of 4, which is 600. And exponent of 1 over 4 is equal to minus 2. Mathematically, from the presentation of our terms, means this one, 1 over 4. When I'm saying mathematically, I'm talking about the calculator view, the view of a calculator. You cannot give a number here raised to, it's impossible, guys, like this. It's impossible, like, let's just, to get a negative from 1 over 4 is like to the exponent of 1 over 4 means the fourth root. It means like this. It means something like this. It's the fourth root of x and give us a negative. Like we cannot have, let's just say here, put a 4 here. We put a positive value. As we can see, the answer is going to be positive, not a negative. We put a negative here and say, okay, let's say a number is negative. What does it? It tells us we cannot have a solution. So there is no way that the fourth root of a number here, the fourth root of a number, because to the exponent of 1 over 4 means the fourth root. The fourth root of a number, it is impossible for it to give you a negative from the mathematical view of our calculator. Anything that we cannot get from that calculator view in our grade 11, we say it is impossible. In our stage, we say it's what? Impossible. So in this case, if we cannot have, theoretically, this is a wrong presentation that we are having, which we are saying the fourth root of x, for the value, we cannot get a negative. It's supposed to be a positive value. I hope we are together there on a calculator. So on this one, we can say there's no solution. So the only solution is on the first part here. Our x is going to be 625. So it is very, very important to say your last answer. You figure it out. You figure it out. The fourth root of a term number inside if this number is an even number, if this number here is an even number, the answer is supposed to be positive. All right? That's the way that we are talking about it now. Like I said, guys, this is for our stage. Mathematics can go beyond that. But for our stage, please, let us just know it this way. All right, so this is it, guys. This is it, 2.22. It was 20 marks, the whole of question 2. So questions can be like that. Do not use a calculator when answering question 3. As this question that we are given, we are not allowed to use a calculator. In the diagram below, we are given the point P minus 68 is a point on the Cartesian plane, and A is a point on the positive side, on the positive x-axis, so that AOP, this angle that we are given, is called theta. All right? With this whole information that we are given, you're now asked to calculate the length of OP. We can simply use the concept of a point. This is the x value. This is the y value. So we can angle here. As we can see, the x values is minus 6. The y value is a positive 8. The OP is this length. This is your OP, which is what? The hypotenuse. You're talking of this hypotenuse. That is our OP. So how do you do Pythagoras theorem? So meaning to say OP, the shorter sides, which is, that's OP squared is our x. That's plus the y value, which is 8. So that's 8 squared. So meaning to say OP is equal to what? Negative 6 squared. It's going to be 36 plus 8 squared, which is going to give us 64. Then add these two, that was going to be 100. All right, so let's introduce the square root, guys. The square root both sides. That was going to give us the length of OP, which is what? Which is 10 units. So that's the whole idea about this question here. So meaning to say this one was going to be 10 units OP. For 2 marks, just use a Pythagoras theorem, guys. You can just use a calculator, straightforward. Even though they say do not use a calculator, guys, you can still use a calculator there. Simplify this one or detail on 3.12. We've got the sine of theta. What are we going to do from our SOHCAHTOA concept? Remember, SOHCAHTOA concept, sine opposite over hypotenuse. So according to our theta, this is our opposite. Remember, this is the adjacent and our hypotenuse. So you just need sine theta opposite, which is 8 over minus 6. Like, we said opposite over hypotenuse, 8 over 10. So that was going to be 8 over 10 plus cos of theta, the cos, the hypotenuse, that's negative 6 over 10. So as we can see, we've got plus or minus, which is going to give us a negative over 10, which is going to give us 2 over 10, and that's the same. You can easily combine the numerators. 3.2, 1 over k. This definitely, you need that right angle triangle that you're just going to indicate to say this is an angle of 25 degrees. And as we are given that the sine of theta, which is the sine of 25 degrees, so the sine is opposite over hypotenuse. Meaning, according to this 25 degrees, what is our opposite? This is our opposite. This is the hypotenuse. So we're already given this is 1 and this is k. That is what you're given there. So you can find the third side so that you can find the tan of 25. The third side. Using our Pythagoras theorem, remember, hypotenuse is squared. As we had that c squared is equal to a squared plus b squared, hypotenuse what? Hypotenuse, which is what? One that we are given the k squared is equal. So you can call it x, you can call whatever that you want. So we need to find x. So that's k squared. 1 squared is 1. Take it to the, you need to find x. So introduce the square root. You have got your x. So x is minus 1 using our Pythagoras theorem. Having the third side, which is our adjacent, allows us now to apply our ratio. As we are saying, the tan of 25 degrees taken from the ratio of a tan is 1 over the adjacent. And what is our adjacent? We take our adjacent, the square root of k squared minus 1. So that is your adjacent. So you're going to take that as it is, the square root of k squared minus 1. So guys, just like that. You see 3 marks. We're done. All right, question 3.3, simplify the following expressions fully without the use of a calculator. All right, so we just need to try by all means figure out these numbers. As you can see, this is more than 360, a complete revolution. So we have to subtract, guys. 698 minus 360 and see if it's going to be It was going to be 338, 338. You have to subtract until you get something that is in within the interval. So this is same as sine 338. Because here I did not simplify, reduce this. I just need positive angles for now. So let's just see the positive, just leave it as it is. Tan 135. 248, as we do understand, it is equal to the cosine of theta. It's an angle which lies in the fourth quadrant as we consider cos minus. But what about minus 248, minus 248? In which quadrant are we going to have that? If we count our angles as minus, we're going to take this as minus 90, minus 180, minus 270. We're going to consider that way. If we're going to consider that way, it was going to be negative, negative, which tends to be a positive. But the answer going to remain as minus, or it is going to remain as a positive, the cos 248. In terms of its presentation, if we use this one, guys, does not go any wrong. Later on, that's where you change it to a negative if you consider the quadrant now. But for this one, a negative for cos, see the effect of a negative later on. So this one, it will be cos 248. Like I said, I'm not reducing these to the acute because they were those angles which are more than these 360 degrees, negative angles. Now we are at positive angles. Let's reduce them into their corresponding acute angles, depending with the quadrant, as we do understand our cast concept. All right, remember your cast concept. Where is this angle going to lie? Is it going to lie in the second quadrant? Is it going to lie in the third quadrant? 338. 338 is an angle that is going to be in the fourth quadrant, more than 270 degrees, but less than 360 degrees. That is where we have the angle of 330, like this. In the third quadrant, where we know that in the third quadrant, sine is a negative, because this is the quadrant of a cos. Sine is a negative. So it is going to be negative sine. So it is going to be negative sine of the acute angle now. This is the acute angle that we need. If the whole of this angle is 338, what about this one that is remaining, the acute angle? Is 360 minus 338. 360 degrees, 360 degrees minus 330 minus sine 22. Okay, so I'm just like, well, which other way can I explain that you can understand me better? But I just hope, guys, because also worked with trigonometry, just also go through the videos so that you can just get a recap, more understanding. 300 degrees is also the same. It is in the third quadrant. Remember, it's for cos from the cast concept in the fourth quadrant. Where it is, it's a positive. So cos is just going to remain as a positive. So that's cos the 60 minus 300, which is going to be cos 60 degrees. You do the same thing, tan 135, maybe somewhere there in the second quadrant. And this is the quadrant for sine. So tan, it's a negative where it is. So it will be negative tan angle here. How do you find the acute angle in the second quadrant? So it will be 145 degrees minus tan 45 degrees. Cos 248. Remember, we changed it before 248. Is 248 in the second quadrant? Is it in the third quadrant? 248 lies in the third quadrant. And this is the quadrant of a tan. 248 is more than 180, remember, but less than 270. And this is the quadrant for tan, meaning to say cos there, cos of the acute angle that is remaining here. So it's minus 180 to get the acute angle. Remember, we need the acute angle. So it was going to give us 68 degrees. This is where we are. At this stage, we can simplify what we can. All right, we can simplify, guys, what we can. Like the negative, we can see them, cancel the negative there. Also, sine 22. For now, let's just leave it. Okay, let's just leave this one and just write a sine 22 degrees times cos 60. Guys, you know your special angles. You do not know your special angles. That does not even make a difference. Because if I have an angle of 30 degrees here, I have an angle of 60 degrees, I have an angle of 30 degrees, make any difference. To say I know that by hypotenuse, so it's 1/2. Knowing this and not knowing, guys, does not even affect even on your calculator. Use your calculator. Yes, they say do not use your calculator, but at this stage, cos 60 degrees, I'm supposed to know it by head. I'm supposed to know it by head. So if I do not know it by head, guys, I can even use my calculator to simplify that. Who is going to know that I've used a calculator? No one. That's 1/2. Hey, some of these things, they say do not use a calculator, but know your boundaries also as you are simplified. Say these ones, I can just use my calculator there. Tan 45, these are the ones that you're supposed to know them by head. Anything that you're supposed to know by head, just 5. Tan 45 is equal to 1. So meaning to say in place of tan 45, we are going to have a 1 there. Multiply this, cos minus 68. We do not have an equivalent. It's just like sine 22 degrees. It does not have an equivalent. That is why we left it here. So actually, we're supposed to write it as minus cos 68 degrees. But this one is going to be a continuous repetition that we have minus cos 68 up to when we can change this at the co-functions. They're relating the considering the cos and the sine, the relationship between these two from the corresponding concept of the angles. If you are given the sine of theta, remember your co-function, 30 degrees minus theta. Meaning to say, if I have a cos here, if I have a degrees minus theta. So can I change this 68 degrees? It is up to you. There it was up to you. It is either you're going to change a sine to a cos, or you change a cos to a sine. Since we have already left this one as it is, let us change what? The cos. All right. So that was going to be negative cos 68 degrees. What is the acute angle? So we've got a negative, sorry. So remember, cos changing to a sine, it will be written as sine 90 degrees minus theta. So it is going to be sine theta, the angle was going to be equal to sine here. Your answer is sine 22. Already not going to change our question to say, is cos going to be negative or is cos? No. The negative that influences the cos is the negative directly on the number. Like, no, those ones, do not worry about those ones. Trigonometry that you're given, the see that cancel sine 22 with a 1 over 1 there, divided minus 1/2. That is what you're going to have at the end. So as you are simplifying, be very careful. The simplification procedures that you are being given, they're just so for question 3.3, that was it. You're having 7 marks, and the whole of question 3, 15 marks. Let's see another part. So I'm just gonna, I think I just had this only. All right, so let me. So if you are to consider question form fully, meaning to say in its up to the simplest form that you can actually have. All right, so that's for 108 times the sine. All right, then this whole part is being divided by tan minus x. There, sine of x 90 degrees. We can just try sine 180 degrees plus x. This is 80 degrees of the reduction. This is 180 degrees minus x. Remember all those guys. So using your casting concept, you can see that where sine is a negative there. So it is going to be reduced to a negative sign. So that's negative sine x. Sine 90 plus x are angles. Sine 90 plus x is positive, meaning to say that cos also must be positive. So it's going to be cos of x. So we know that tan minus x is a negative angle. In the fourth quadrant, tan is a negative there. So this is same as we've got minus tan x. So for negative angle minus x, it is only cos which is positive. Sine is changing it. It changes to a positive. Plus the sine of x. Can we do something there? No, let's just rewrite as it is. The sine of x. What about cos 90 minus x? We saw this, guys. I talked about this. Cos 90 minus x is equal to the sine of x. We saw we need to assign x is changed to cos 90 minus x. So we are now having that cos 90 minus x. It will change to a sine x. So this is the cos 90 minus x. It now gave a sine x. This is where we are. Remember, they were just told to simplify in its simplest. We are not given an answer that express it. So let's try to figure out negative multiply, guys. We have got that power to multiply these two. So let's combine these and see what you're going to have. Sine and cos, that can just be written as x, which is being divided to a tan. Divided to a tan that we know it is equivalent to a sine x over a cos x. So what does it mean? It simply means this part, when we are saying divided to a tan, we can write it like this: divided to over this, over that tan, divided to sine of x over the cos of x. We have just changed this. Division divided to division, tan sine over cos. So this is the whole part of our numerator divided to the denominator that we had before. This is what it means. So the rest is going to remain as it is. So we've got sine squared pi as we are seeing the division. As long we work with the division, we change it to cos of x times. The moment you multiply, you invert the second fraction. There's going to be tan of x. Everything that's at the end. All right, this is just a normal multiplication. Fractions we do understand, guys, as we are given these fractions, can even cancel the denominator and the numerator is, as long as there's something common, if you multiply cos times cos plus that part, you still have that sine squared. And normal Pythagorean identity that we are used to, which we know that this is equal to what? To a 1. Remember, cos squared x plus sine squared. That is your basic Pythagorean identity. You must know that. So, guys, there's nothing that we can do now. We are fine. You just have to be careful. Try basics. 4.2, you're given this, and 4.21, you're given to prove this. That's 4.21. It's either you're supposed to prove the left-hand side equal to the right-hand side. It is up to you. But already you're given, the given part is this one. So when they've already given that part that you're given is equal to this. So like I said, you can prove from anyway, you can use the left. I'm just going to use, we are already given, this is the sine of theta over 1 plus the cosine of theta. Working with your trigonometry, you can also agree with me that this type of an identity that we need to prove like this one, we need to introduce something familiar to the answer because we do not have that in our question. But on our answer, there we can see the 1 minus cos. So we introduce that. But how do we introduce something that is not part of our question? You don't have that, but you want to introduce it. You multiply it both the numerator and the denominator. By doing this, guys, we haven't changed anything because this will cancel, give us a 1. We are back to the original question here. So we haven't changed anything here. We haven't changed. We haven't posted it can cancel like this. We haven't changed anything. But as we are not going to cancel, because if you cancel again, we'll go back to that original question, meaning to say we are just playing around the same thing. You introduce, you cancel it. You introduce, you cancel. No. Introducing both to the numerator and the denominator is to neutralize your question. Meaning to say at this stage, you can do whatever that you want because it is the same as what you had before. But it allows you now, if in case the sign, it's going to multiply the numerator if you want. But since we have got the 1 minus, not cancel, sine theta into 1 minus cos, everything over. All right? 1 plus cos theta, 1 minus cos theta is supposed to multiply this one. But what is it that we are seeing? A difference of 2 squares. A difference of 2 squares that we are seeing. Isn't it? Where was it? 2 brackets. Where were they taking theta? Difference of 2 squares. Because you can see that this one and this one are exactly the same. Only that one is having a positive, another one is having a negative. So it becomes a difference of 2 squares. And 1 squared is same as 1. So that's 1 minus cos squared theta. So this is where you are. All right. This is where we are at this stage. And simplifying this, remember, we just want to reverse our question here to this stage. And we have the 1 minus cos of this because it is what we need at the end. So just leave it like that. Do not expand the brackets because we can properly see that one. But we can simplify 1 minus cos squared theta from our identities. Remember that Pythagorean identity that we proved before, that we're simplifying before when we're talking about the cos squared of theta equal to 1. How can we obtain 1 minus cos squared from here? It means we took it to the other side of it with what? Sine squared. So it is going to be like this, sine theta. So if that is the case, sine squared theta, therefore let's remove it. Let's remove this one because they're the same. There is a sine theta into 1 minus the cosine of theta. Everything like this over what? The equivalent of 1 minus cos squared, this as sine squared theta. Now you can see that these two can cancel since we have the product. So the sine theta into sine theta, that's a 1. Sine theta into sine squared, there are 2 of them there. The squared means there are 2. So if you cancel, you're going to remain with 1 sine theta. There were 2. So you cancel 1, you're going to remain with 1. So that is exactly what over the sine of that this is equivalent to what you had on the right hand side. So questions can be like that. Like I said, you can even prove from the right hand side. Introduce what is not here. 1 plus from the right hand side. Guys, that one is in your hands. Of theta. In this interval from 0 to 360 degrees, we need a value that is going to satisfy a condition that sine theta over 1 plus cos theta is undefined. Undefined 1 over zeta over a 0 does not exist. Undefined. We have a fraction. So the undefined part, when it is to be considered on a fraction, it's all about the denominator. A fraction, once you have a fraction, the denominator here, once it is equal to 0, that fraction is undefined. That fraction becomes undefined. That the whole statement becomes undefined if the denominator is equal to 0. So by making that statement, it means we have an equation because we are saying the denominator 1 plus cos theta, that's our denominator. It must be equal to 0. So I have formed an equation that I can solve for theta. So the cosine of theta is equal to what? 1 to the other side, that's a -1. We are dealing with a cos at -1, guys. We know that that will be 180 degrees, or you can use the reference angle. If you're using the reference angle concept, remember I said do not use the negative. So it is just going to be arc cos of 1, and arc cos of 1 is going to give us 0 degrees. But wait, are you going to have a 1? You can also cosine. This is 0, this is 90. This is 0 there at 1. This is 360 with what? -1. So therefore, your theta there was going to be 180 degrees. There are those angles that you call special angles. Then there are also some special properties of trigonometric identities as you're considering your ratios. Angles such as 90 degrees, 180 degrees, 270 degrees. Those ones, guys, we're supposed to know them. Theta is equal to 0. If the cosine of theta is equal to 0, these ones, know them also. Try to know them by head. What is the theta? If the sine theta is equal to 0, what is the theta that will be there? Meaning to say we're talking of 0 degrees, 180, 360. We talk of the graph of what? Of sine. All right? At 0 degrees, at 180, at 360. It will be at 0. What? At -1, that's 270 degrees. For the graph of cos, 0, it's at what? It's 1. When it was, let's say it was a +1 here, our answer was going to be 0 degrees. And I don't know how best can I explain? When it is 1, when it is a -1, when it's different from finding of the reference angle when you've got decimals like cos theta is equal to 0,5. I have to find the reference angle, then check from those quadrants. These ones, you need to know them. Try by all means, guys, to just have the basics. Or what can I say? Using the general solutions. As the general solutions, they do not limit you. If you understand the general solutions, they're also best to use in such a circumstance like this. When we face such a circumstance, it is also another best way. But because of time, guys, just need to come back again, revise as much questions as we can, and all this doing it in light so that we prepare ourselves for the exams which are ahead of time. Till we meet again.